Our next example is cosine x divided by 2 plus sine x. We'll start off by looking at its domain, and you should note that 2 plus sine x is always positive because the sine of x has range from -1 to 1. So 2 plus sine x is going to have a range between 1 to 3. So the denominator is always a positive number, which means it is not 0. So cosine on the top is a number between +1 and -1. The number on the bottom is between 1 and 3. So the domain is all real numbers. So no vertical asymptotes. Next, we want to take a look at the zeros of the function. We notice that to find zeros, we just have to set the numerator equal to 0, which is the cosine of x. For recalling your unit circle, if we think of our angle theta, we know that the cosine of our angle is the x value on the unit circle, so the x is 0 on the top and the bottom of the unit circle, so there are zeros at pi/2 and 3 pi/2. Notice that this is also going to have zeros every multiple of pi, so pi/2, 3 pi/2, 5 pi/2, 7 pi/2, 9 pi/2, and so on. So we can say pi/2 plus an integer multiple of pi. Also, notice that the top part of this equation and the bottom part of this equation have a period of 2 pi. Cosine and sine both have periods 2 pi, so this equation is going to, the graph of this is going to be periodic with period 2 pi. Moving on to first derivative information, we're going to do the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times top, all over the bottom squared. From here, we'll distribute the negative sine x and multiply the cosines together. Notice that since we have negative sine squared minus cosine squared, we can factor out a -1, and that gives us sine squared plus cosine squared, which this is the Pythagorean identity, and we know that is 1. So -2 sine x minus 1 on the top, which we can factor out that -1, and a 2 plus sine x squared in the denominator. So we want to know when 2 sine x plus 1 is 0. So solving for that, we want to know when sine x is equal to -1/2. Since the sine is the y, our y is going to be negative in the third and fourth quadrants. So when our angle is 7 pi/6 and 11 pi/6, that'll give us a -1/2. We use those values to get our critical value. Those are our critical values, and from that we'll get our test values and do a number line. When x equals 0, sine of 0 is 0, so 2 times 0 is 0, plus 1 is 1. The opposite of that is a negative number up top. Notice that the denominator is always positive for this fraction, since you have already noted that 2 plus sine x is a number between 1 and 3, and when you square it, it will be positive. So our number line becomes something like this: decreasing, then increasing, then decreasing. Notice at 0 and at 2 pi, those have the same sign. That's not surprising, since we noted earlier that this function was periodic with period 2 pi. So we end up with a local max and a local min, or a local min and a local max. Now we're going to take the derivative, and we can use any of these first derivative lines to take our second derivative, but the most convenient one to use would be the final one. Taking our derivative using the quotient rule, we have derivative of the first, derivative of the top times the bottom minus the derivative of the bottom times the top. Notice that we have a negative in this in the top, so I'm going to make that positive. Also notice that we have an inside derivative chain rule from the derivative of the bottom. Next, we're going to look for pieces to factor. Looks like we've got a 2 that can be factored, a cosine x that can be factored, and a 2 plus sine x that can be factored out. So I'm going to factor all of those out. And what's left is a negative 1 of the 2 plus sine x's plus, that's been factored, that's been factored, that's been factored, a 2 plus sine x, 2 sine x plus 1. At this point, we can simplify one of the 2 plus sine x factors with the denominator to end up with 3 of those. And combining like terms gives us 2 cosine x times negative 1 plus sine x over the denominator. We saw the denominator again is going to be positive because it's a number between 1 and 3 cubed, which is positive. The 2 plus cosine x is 0 when x is pi over 2 or 3 pi over 2. And negative 1 plus sine x yields the same kind of thing, just pi over 2. Sine is positive at the top there at pi over 2. So that doesn't add anything new. We can draw our number line and test these. When x is 0, 2 times cosine is 0. Cosine of 0 is 1, so 2 times 1 is positive. Negative 1 plus sine of 0. Sine of 0 is 0, so that is negative here. The denominator is always positive there, so it is positive times a positive, which is concave down. At pi, cosine of pi is negative 1, so we have a negative. And sine of pi is 0, so negative 1 plus 0 is negative. Negative times a negative is positive, so concave up. Then, using the period of the function, it starts repeating. Putting all these things together, we notice that we have a point of inflection at pi over 2 and a point of inflection at 3 pi over 2. Those were also zeros of the function. So the function is decreasing and concave down from 0 to pi over 2. Then it's decreasing and concave up from 0 to 7 pi over 6, where it has a minimum. Then it's increasing and concave up till it has a point of inflection at the 0, and increasing concave down until it has a maximum at 11 pi over 6. Then it starts repeating again. That is the max. And if we go the other direction, we would see a max there to the left at negative pi over 6. So from here to here, is 2 pi. And that's the end of that.